Okay, so this is the part that most people find difficult. It's the maths bit. Very, very easy. Now, before we start, guys and girls, what I'm going to get you all to do is pause this video and write down those questions that are on the screen. Okay, that's all I want you to do. Pause the video and write down those questions. Once you've done that, carry on. I'm going to delete this now because you should have paused it and written, who cares, them down. So I'm going to answer these questions now. I'm going to go with answering A first, obviously. So now what we need to do is we need to look at the question and we need to split our page up. Okay, so the question was to do, this is A. The question had two parts to it. It asked about hydrogen and it asked about oxygen. So I'm going to split my page down the two ways. Now this method, to remember how to do this method, guys, I'm going to tell you that you need to remember Lady Gaga. Lady Gaga. Right? And the reason why is because this bit here, AR, is the short way of writing relative atomic mass. And G stands for grams. So I mean, if you can't be bothered to remember that, just remember Ga and remember the grams comes first. I'll explain in a bit. Now from the question, they're going to give you the grams, the mass of in grams of your elements. So from the question, they told me it's 0.6 grams. Can you see how Gaga comes in use? The grams I'm going to write first, and the oxygen they told me was 4.8 grams. So that's that done. Next, what I need to do is I need to find the relative atomic mass, and you'd get that from the periodic table. So the relative atomic mass, that's the big number, or the number at the top for hydrogen, is 1. The big number, the number at the top for oxygen from the periodic table, guys, is 16. So can you see how it's grams first, then the relative atomic second? So it's Gaga, grams first. Now I need to divide the grams by the relative atomic mass. Again, the Gaga comes into use. The G needs to be on top, the grams needs to be on top, and the other bit needs to be at the bottom. That's why I call it the Gaga method. So it's to remind you that the grams goes on top and the relative atomic mass bit from the periodic table goes at the bottom. Same with here. So it's 4.8 grams at the top, the Gaga method, divided by 16. So now that I've done that bit, I need to actually work it out. So I'll get my calculator, which I've already done, and 0.6 divided by 1 is 0.6, and 4.8 divided by 16 is 0.3. If you do it in your calculator, that's what you'll find. Now, what you need to do in the next step is, once you've got this ratio, you're almost there. So this is the ratio bit. You've got this ratio. All you need to do is you need to divide both bits, so this bit and this bit, by the smallest ratio. In this case, the smallest ratio is 0.3. So I'm going to say 0.6 divided by 0.3. So it's the small man at the bottom always. And 0.3 divided by 0.3. So this is going to equal to 2, and this is going to equal to 1. So what this shows us is that the empirical formula for hydrogen is going to be 2, and how many oxygens am I going to have? I'm going to have 1. Well, we know this anyway, because we know that water is H2O, and all empirical formula means is the lowest number of atoms that water will have. So the ratio of atoms in its simplest form. So the lowest number of atoms in its simplest form, while hydrogen you're going to have 2 of them, oxygen you're going to have 1. And that's what we've just worked out. H2 and O1. So H2O, that's water. So I hope you understand this Gaga thing. So it's grams, and then you're going to divide it by the next bit. Grams is on top. And once you get your ratios, you're going to divide both or all of the ratios by the smallest ratio, and that'll give you your end answer. So guys, have a go at number 2 yourselves. Pause the video at B, pause the video, have a go at B, and see how you do. Remember to make the columns for each section. Now for B, so you can pause it now and then unpause it once you're done. So with B, what I'm going to do, I'm going to draw my headings first. So I've got lithium, after which I've got carbon, and after which I've got oxygen. Right, so from the question, now guys, the grams they will give you in the question. The grams they will give you in the question. The grams they will give you in the question. Anyway, so it's 2.8 grams for lithium from the question, 2.4 grams of carbon from the question, and with oxygen it was 9.6 grams from the question. So that's my gaga bit. So I've got the grams first. Now I need to get the relative atomic mass. The relative atomic mass I get from the periodic table. It's the top number. So for lithium it's 7, for carbon it's 12, and for oxygen it is 16. Happy days. So what's going to happen next? We're going to now do the gaga. So it's the grams divided by the AR, the relative atomic mass, which is 2.8, so the grams is on top, 2.4 grams, put the G there guys so you remember that the G is on top, divided by 12, and 9.6 G for grams divided by 16. Brilliant. Let's get our ratio. So once you do this bit, you end up getting your ratio, which means that you're almost done everything. So 2.8 divided by 7, I've already done it on my calculator, it's 0.4. 2.4 grams divided by 12 is 0.2, I've already done it on my calculator. And 9.6 divided by 16 is 0.6. So once you've got your ratio, here's my ratio bit. Yeah. So once you got your ratio, just write down ratio just to remind you that you're almost there and that there's nothing to worry about. We're going to divide it by the smallest ratio. All of these bad boys are going to be divided by the smallest ratio. So what is my smallest ratio? In this case, it's this number here, which is 0.2. So let's go and divide those all by 0.2. So 0.4 divided by 0.2. Now at the end, the little man goes on the bottom. So 0.2 divided by 0.2 and 0.6 divided by 0.2. So 0.4 divided by 0.2 is 2, this is 1, and this is 3. 0.6 divided by 0.2. So what does this mean? What this means is that we've got 2 lithiums. How many carbons? 1 carbon. How many oxygens? 3 oxygens. So our empirical formula is Li2, so there's 2 of those, C, 1 carbon, O, 3 carbons. And that is our end answer. Well done guys and girls. Now again, I'm going to go for C. Do it yourself. Use your headings. Do the Gaga method. Think about the smallest ratio. Think about the small man on the bottom. That's weird. Don't think about that. Now, where was I? So what I've got is I've got my 3 tables. Potassium. I've got my nitrogen, because that's what the question told me. And I've got, finally, I've got oxygen. Right, so again, we're going to use our Gaga method. So the grams from the question, the grams is 5.85 grams. Nitrogen is 2.1 grams. Guys, don't forget to write the grams in, okay? It just makes life easier, because you can remember the Gaga method then. And oxygen from the grams from the question is 7.2 grams. Next, what do I do next? Let me change the color. I'm going to get my relative atomic mass from the periodic table. The top number, the big number, the heavy number, the one at the top. So for potassium, it's 39. For nitrogen, it's 14. For oxygen, it's 16. What do I do with these numbers? Well, it's the Gaga method, so I'm going to have to do the grams divided by the AR. So I'm going to do 5.85 divided by 39. I'm going to do 2.1 grams. Oh, put the grams in, guys, so you don't forget the Gaga method. Divided by 14, and 7.2 grams divided by 16. So let's get the answer to those questions. Now I'm on the ratio, and I'm going to think of the small man. And so 5.85 divided by 39. I've already done this on my calculator. Let's change the color. Why not? It's going to be 0.15 These are my ratios, 0.15, and this one is 0.45. Right, so the last bit, like I said, is to think of your ratios and the small man on the bottom. What is the small man on the bottom? It's the 0.15. I'm going to do 0.15 divided by 0.15. That's going to give me 1. 0.15 again divided by 0.15. And finally 0.45 with the little man on the bottom, 0.15. So this is going to be 1 to 1 to 3, because 0.4, if you do it on your calculator, you'll get that 3. So what does this mean, guys and girls? This means exactly the same thing. There's nothing different here. We're going to have 1 potassium, we're going to have 1 nitrogen. How many oxygens we're going to have? We're going to have 3. So the empirical formula, potassium nitrate in its simplest form, in terms of its number of atoms, is 1 potassium, 1 nitrogen, 3 oxygens. Bam, potassium nitrate, done. And that is empirical formula done, guys. Remember Gaga method, remember the table, remember the ratio, remember the small man on the bottom. It's all good. It's all done and dusted. Yeah, that's what I'm talking about. That's what I'm talking about. Yeah.